Hey guys, how you all are doing? I hope you all are doing fine as always. So last time we started with staining of organism series, and there we studied about majorly introduction, but also the main thing that we studied there was chromophore and oxochrome, the parts of stain. I hope you remember it. So in this slide, we're going to talk about types of stain available in the laboratory to stain different types of organisms, and how or on the what basis we have classified these stain. Basically, we have classified these stain on the basis of two major types, on the basis of two major category. Okay, the first category is the chromophoric charge. I hope you remember that a stain consists of two parts, a chromophore and an oxochrome, right? So whenever a stain dissociates, a chromophore consists of some charge. So what kind of charge does it have? A positive or a negative charge? On the basis of that, we have two types of stain. Or the next category includes chromophore type. For example, a molecule might have a nitro group. A chromophore might have a nitro group, or let's say methane group. So on what basis, or in fact on what type of molecule or what type of um, atoms a chromophore has, on that basis we have 8 different types of stain. First category, based on chromophore charge. Now whenever stain molecule dissociate, it gives ions, or we can say chromophore and exochrome, and then the chromophoric part can either have a positive or a negative charge, as I said. Now acidic stains is a first type of stain. In this type of stain, chromophore has negative charge. Okay, and the examples can be picric acid, eosin, India ink. I want you to look at this picture. Like, see, this is your picric acid benzene ring, 3 nitro group and a OH. So whenever this picric acid dissociates, it gives us chromophore and a hydronium ion. Now if you look at this chromophore or the picrate ion, you find your negative charge over here over oxygen. So this kind of a chromophore having negative charge are called acidic stain. Eosin, if you see here, we have sodium plus and eosinate. So eosinate has negative charge. So that's how we classify them as acidic stain, chromophore having negative charge. The second one is basic stain, chromophore having positive charge. I'm just really sorry, it's positive here. Chromophore having positive charge like methylene blue, safranin, malachite green. Methylene blue, when dissociates, it gives us methylene blue plus and chloride minus. So here see, methylene blue plus consists of positive charge, and for that we call such stains as basic stains. Finally, we are here on the chromophore type. We have first as nitro stain. Chromophore consists of nitro group. Like see here, we have chromophore as a picrate ion, right? Picric acid is a nitro stain because picrate ion, when picric acid dissociate, is give us chromophore, which is a picrate ion, and that picrate ion consists of NO2 nitro group basically. In such type of stains where chromophore consisting of nitro group is called nitro stains. The example is picric acid. Second type of stain is azo stain. Here the group, chromophore group, consists of azo group. Okay, this is your azo group. This thing is your azo group. Now it, if there's one azo group, it'll be called as monoazo stain. If there are two azo group, it'll be called as diazo stain. If there are more than two azo group, there will be it'll be called as polyazo stain. We have examples as Congo red, methyl orange, trypan blue. So these are kind of azo stains. Why? Because they have azo group. Now if we talk about methyl orange, it's monoazo. Why? Because we have only one azo group over here, and it's acidic in nature because whenever it dissociates, this is your chromophore. I hope you can make out. Now this is your acidic stain. Why? Because it is having your negative charge, and it functions as pH indicator. The another one we have Congo red. If you see here, we have two azo group. One is here and the second one is here. So we have two azo group, and functions of this Congo red, it acts as acid base pH indicator, cell wall staining of bacteria, and histology staining like for tissue staining and all. But the one thing that we need to make a note of it is we really need not to remember all the stains. It's just that whenever we are dealing with stains, we need to know that there's something called chromophore. The chromophore can be classified as nitro or azo stains on that basis, like on the what group it's containing. It just to know something about it. It's nowhere important that okay, bring that azo stain from that a particular table. Nobody gonna tell you that. We all gonna tell you, okay, bring the Congo red stain. It's just that we are trying to classify having some sense and some connection with stains. Okay, third one is your anthraquinone stain. Okay, now quinoid ring is a chromophore and it's your acidic stain, because you can say that whenever this stain dissociates, chromophore consists of negative charge. Your example is alizarin and purpurine. Now this is your alizarin. If you're wondering what is your quinoid ring, then this kind of a ring where the middle ring consists of two such bonds and a three pairing of such ring is called your quinoid ring, and such type of stains consisting of such type of rings are called anthraquinone stain. So this is your alizarin structure and this stain is red in color. Moving ahead, we have thiazole stain. What is thiazole stain? Consisting of thiazine ring, in which endamine group is a chromophore. For example, we have titan yellow and thioflavin S. So this is your titan yellow structure. We have thiazine ring in which endamine group is a chromophore. For example, we have such type of rings are called thiazine ring. And since here we have no, so endamine group is your N and double bond N. So we have thiazine ring. In that we have endamine group. This one is your endamine group, and that endamine group is present in your chromophore. So such type of stains which having thiazine ring and endamine group as a part of a chromophore, such stains are called thiazole stain. Examples are your titan yellow, thioflavin S. And these are again pH indicator, fluorescent indicator. Will the time of using them when we are dealing with how to stain any cell wall or how to stain any nuclear material, when we'll be using them, we'll be dealing with them again. Fifth one is your quinonimine stain. Two chromophores, endamine and quinoid ring. So here we have two chromophores, and we have endamine as well as your quinoid ring. So this is your endamine group as we have just studied, and here you have quinoid ring. Okay, middle structure having double bonds like we have studied there. So such type of stains having two chromophore, like here we have endamine and we have also have quinoid ring. Such stains are called quinonimine, and we have examples as methylene blue, azure A, azure B, natural red, and this is your structure for methylene blue. Moving ahead, we have phenylmethane stain. Now, this is a very kind of an interesting stain, because this type of stain not only includes a particular type of a stain, in fact a variety of stain. What am I saying? I'm saying that a substituted methane acts as a chromophore, and substituted methane can be substituted by anything, like if I have CH4 here, CH4 over here, and when hydrogen atoms are replaced by methyl, they can be replaced by ethyl, they can be replaced by phenyl group. So on that basis, we have variety of phenyl methane stain. For example, here we have malachite green. Okay, this is your malachite green. Now this is your C group, which is replaced by three phenyl groups. Okay, so that results into the formation of malachite green. Here again we have C group, which is replaced by another set of phenyl group members, and this is your example of basic fuchsin. So on the basis of how a carbon atom is substituted, or in fact hydrogen atoms that are attached to methane are substituted, on that basis we have variety of phenyl methane stain, but the basic general term for all such type of substituted methane chromophores remains the same, which is phenyl methane stain. Other example is your crystal violet. Moving ahead, we have xanthene stain. Xanthene structure is given here. Xanthene derivatives are acting as chromophore. Like for example, here we have xanthene derivative, not a xanthene structure, right? Yeah, here we have some kind of modifications in the middle ring. So xanthine derivatives are acting as a chromophore, and they are mainly fluorescent dyes. So it could be the example pyramine stain, fluorine stain, phenolphthalein stain, acridine stain structures is given over here. So such type of stains having xanthine derivatives as chromophore are called xanthene stain. Last but not the least, we have natural stains which are obtained from natural resources like plants or insects. Now indigo is an example of natural stain which is obtained from plant, and it is deep blue in color, and it is used generally to stain fabrics. Caramine, the spelling is wrong over here. It's Caramine. So let me write it for you. Caramine. Caramine. I'm sorry. Okay, so caramine over here is an again a natural stain which is obtained from insects, red in color, and it is generally used to stain nuclear material. Now again, let me put this in more specific words. We need not to remember examples of almost every stain. This is just an introduction to different type of stains so that you get familiarized with stains like trypan blue or caramine or indigo or titan yellow or methylene blue. It's just for that. Otherwise, stains classification is generally not asked in papers, and yeah, that's it. It's just for your introduction, for your kind of knowledge that okay, such kind of thing also exists in microbiology. With that, thank you so much, guys, for hearing me out. I hope I have not bored you with this lecture, because upcoming staining lectures will be, of course, interesting. If you know about gram staining, if you know about acid fast staining and still having problems with it, don't worry, the upcoming lectures will clear all your doubt. And still, if you want to know about something or other, or if you want to put up your great ideas related to microbiology, I'm open with it. Go see the mail ID in the description and put your doubts over there or your great ideas. Hoping to see you next time. Bye bye. Take care.